All right, so we're starting on section 5.1, which is on quadratic functions. Now, we've talked a little bit about quadratic equations before, back in chapter 2, where we figured out how to solve quadratic equations. We could factor, right? We could use the square root property. We could use the quadratic formula. We could use completing the square. We're going to be using all of, well, your choice of those skills to work with quadratic functions. So we're thinking about the graphs here, the characteristics of parabolas, which is a graph of a quadratic function, figuring out how the graph of the parabola is related to its function, if it has a minimum or a maximum, things like that, solve problems involving quadratic functions. So we're also going to be using the skills we learned with transformations from chapter 3. So hopefully you guys remember the vertex, right? That is the point at which the graph of the parabola either stops increasing and starts decreasing, right? So that would be this point on this parabola right here, or vice versa, stops decreasing and starts increasing. So you can see each one of these two parabolas, each one has a vertex, okay? Now, so some other terminology. If our graph is concave up, that means it holds water. If we were to pour water on it, then the vertex is a minimum. So if the graph opens up, it is concave up. Our vertex is the lowest point on the graph. Point on the graph. Okay, and if the graph is concave down, which would mean it doesn't hold water, then our vertex is a maximum. Let's see, we'll just go to the next slide. There we go. There we go. Right, so the highest, so the lowest point on the graph when it opens up is the minimum. Highest point on the graph when it opens down, that's our maximum, right? So vertex will have either a minimum or a maximum, but not both. Okay, so so vertex form. So hopefully, we talked about the graph of f of x equals x squared, right? That's your plain Jane parabola, right? Something like that. I can't draw very well, right? But we know its vertex is at the origin, at the point 0, 0. So if we think about a more complicated version of our parabola, f of x equals 2 times x minus 3 quantity squared plus 4, this is really just the same graph of x squared, but it's had several transformations applied, right? We can look at this and say, okay, the x minus 3 quantity squared, that's an inside change. That is a horizontal shift to the right. The plus 4, that's going to be a vertical shift up. 4, and to the right was right 3 units. I forgot to say that. And this one has one more transformation, right? The 2 here is a vertical stretch by a factor of 2. So we can see if we graph this thing that you can see, there we go, flip upside down. We can see if we graph this thing that really it just is those changes, right? So if we take y equals x squared, there's our plain Jane vertex. If I do y equals x minus, what was it, 2? 3. X minus 3 squared, that is shifting over to the side. So let's see, and let's apply our stretch. Right, so you can see I'm going to change the color on this. I don't know why they're all going all just in black. I don't know. But there's our stretched one, and then of course if we just apply the, shift, was it up 4 or down 4? It was up 4. So you can see there's our last one, right? It is just the same parabola, really, just a series of transformations. There we go. So first over to the right, then stretch, then shift up. There we go. Okay. So, sorry. So vertex form, which is really what this is in, it's the transformed form of the parabola, is going to give us the location of the vertex. So we've got A. This is the same A from when it's written in standard form. So we'll go right over here. Standard form of a parabola. Y equals ax squared plus bx plus c. So that is the same A in the standard form as in the vertex form. But the advantage of the vertex form is that it's going to tell you exactly where the vertex is, right? Because you're going to take that 0, 0 vertex and shift it over left or right by h, and you're going to move it up or down by k, so that you automatically know where your vertex is if you have it in vertex form. And of course, the max or min of the function occurs at the vertex. It's one or the other, but not both. Okay. So we'll do this one and then we'll break for the next video. So vertex form, what does the A do to it, right? If the value of A is between, so it's the same transformation, same vertical stretch stuff as in chapter 3. If A is between 0 and 1, it's been compressed or shrunk, right? So our original parabola might look like that, and our new one with an A value that's like 1/4 x squared would look like somebody sat on it, right? It would look wider. And if it's greater than 1, it's going to look like we stretched it, right? It's going to look narrower. There's an example. And of course, if A is less than 0, it's been reflected over the x-axis, right? There is nothing new here, nothing new, because we've talked about all these transformations before. Okay. So of course our vertex is at h comma k, and our axis of symmetry's got to go through that vertex. So it is always going to be x equals whatever the x coordinate is of the vertex. All right, so this is a good place to break. We'll go to the next video.